This video is presented by Pioneer Career Kolkata.
Welcome to Pioneer Career. Today we are going to discuss last two digits of any expansion and factorial. Basis of this theorem is binomial theorem. So first we will discuss binomial theorem. Let's start with the binomial theorem. If a plus b to the power 1, we all know it is equal to a plus b. Next is a plus b whole square. If we do the expansion of this, we all know a square plus 2ab plus b square. Then next is a plus b cube. This is equal to a cube plus 3 a square b plus 3 ab square plus b cube. Now, can you write it on a plus b to the power 4? Is there any pattern? Yes, we do have some pattern. So first of all, we will look at the coefficient of this expansion. If you look at the coefficient, it follows certain pattern. Here we have a coefficient 1 and 1 for the first one. For next one, we have a coefficient 1, 2, 1. 1, 2, 1. For next one, we have a coefficient 1, 3, 3, 1. 1, 1 plus 2, 3, 2 plus 1, 3, and then 1. For next expansion, we should have start with again 1, 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4, and again 1. So for this particular expansion, we have got the coefficient. This particular triangle is called Pascal's triangle. So first coefficient of this is 1, then next coefficient is 4, 6, 4 and 1. If you look at the pattern, it always starts with highest power of first variable and lowest power of second variable. So we will start with a to the power 4. Next coefficient is 4. Now this power will reduce a cube and b to the power 1. Sum of these two power must be equal to 4. Next coefficient is 6. This will reduce to 2. This will increase to 2. Then next coefficient is 4. This will reduce to 1. This will increase to 3. Next coefficient is 1. So a to the power 4. Now similarly we can write down a plus b to the power 5. If you look at the coefficient again, coefficient will be 1, 5, 10, 10, 5, 1. So these are the coefficient of the expansion. Now if you write the a plus b to the power 5 expansion, we will get a to the power 5. Next coefficient is 5, so 5. This power will reduce to 4, so a to the power 4, while b to the power 1. Sum of power should be equal to 5. Next coefficient is 10. This power will reduce to 3, b square. Next coefficient is again 10. This will reduce to 2, b cube. Plus next coefficient is 5. This will reduce to 1 to the power 4. Last coefficient is 1. That is equal to b to the power 5. So in this way we can write binomial expansion. Now let's generalize the terms of binomial expansion. A plus b to the power n. First term is n c 0, a to the power n, b to the power 0. Sum of the power should be equal to n. Next term is n c 1, a to the power n minus 1, b to the power 1. Now in this way we can see that the power of a will keep on reducing and power of b will keep on increasing. Similarly, and the last term will be n c n, a to the power 0, b to the power n. Rth term is given by n, c, r minus 1, a and b. Whatever is given here, we can put here r minus 1. Sum of these two powers should be equal to n. So this will be n minus r minus 1. This is the rth term of any binomial expansion. Now let's discuss last two digits of any expansion. We'll categorize it. Category 1 we'll discuss. Category 1 we'll discuss when a number ends with 1. Category 2 when number ends with either 3, 7 or 9. Category 3 when number ends with even number. So we'll discuss one by one. So first of all, category 1, the number that ends with 1. Now we have to find out last two digits of 21 to the power 147. We'll do the binomial expansion of this. 21 we can write down as 20 plus 1 to the power 147. Now if we do the binomial expansion of this particular term, first term will get 147, C 0, 20 to the power 147, 1 to the power 0. Next term or second term will get as 147, C 1, 20 to the power 146, 1 to the power 1, and so on. Second last term will get as 147, C 146, 20 to the power 1, 1 to the power 146, and last term that will get is 147, C 147, 20 to the power 0, 1 to the power 147. Now, if we look at the terms previous to the second last term, here we have 20 to the power 0. Previous term must have 20 square, so last two digit of previous term must be double 0. Similarly, last two digit of previous term must be 0. So, apart from the last two terms, each and every term has last two digit as double 0. So, last two digit of this particular expansion is decided by these last two terms only. Look at this term. 147, C146 is equal to 147, 20 to the power 1 is equal to 20, 1 to the power 146 is equal to 1. So last two digit of this expansion is, last digit must be 0 as we have 0 here, and second last digit is 7 to the 14, 4. So last two digit of this particular term is 40. Now look at this term, the last term of this expansion. This term is equal to 1, this term is equal to 1, this term is equal to 1. So last two digit of this last term must be 0, 1. So last two digit of this particular expansion must be 40 plus 0, 1, that means 41. Hence we can say that last two digit of 21 to the power 147 is equal to 41. Now let's take one more example. Say we have to find out last two digit of 171 to the power 149. First of all, last two digit is governed by only last two digit. This one has no role to play. So last two digit of 171 to the power 149 is same as last two digit of 71 to the power 149. Again, if we proceed with the binomial expansion, we will get 70 plus 1 to the power 149. If we do the binomial expansion of this particular term, we will get 149 C 0, 70 to the power 149, 1 to the power 0. This is the first term. Second term will get 149 C 1, 70 to the power 148, 1 to the power 1, and so on. Second last term will get as 149 C 148, 70 to the power 1, 1 to the power 148. And the last term that we will get is 149 C 149, 70 to the power 0, 1 to the power 149. Now if you look at the last term, this is equal to 1, this is equal to 1, this is equal to 1. So last term of this expansion has last two digit as 0, 1. Now look at the second last digit. 149 C 148 is equal to 149. This is equal to 70. This term is equal to 1. So product of this one last digit must be 0 as we have 0 here. Second last digit is given by 9, 7 are 63. So we have 3 here. Third last term must have 70 square. Means last two digit must be 0. Fourth last term must have 70 cube. Means last two digit must be 0. Hence each and every term apart from last two term we have last two digits must be 0. So last two digit is given by summation of last two digit of second last term plus the last term, that is 30 plus 01, that means 31. Hence last two digit of the given expansion, that is 71 to the power 149 is equal to 31. Now let's generalize it with a formula. Say we have to find out 81 to the power 149. Last two digit of this one. Last digit must be 1 as we have 1 here, and second last digit. So in the entire process we have to find out only second last digit. If you look at carefully, second last digit is the product of unit digit of 9 and 8. 9 8 just 72. So 2 is the second last digit here. So last two digit of this particular expansion is equal to 21. The same logic we have applied here also. If you look at the first that we have discussed, 21 to the power 147. So last digit must be 1. Second last digit is product of 2 and 7. That means 2 7 are 14. So 4 is the second last digit. So last two digit of this expansion is equal to 41. Similarly, if we look at this one, 71 to the power 149. Last digit must be 1 and second last digit is given by product of 7 and 9. 7 9 is 63, hence 3 is the second last digit. So last two digit of this particular term is equal to 31. Let's take one more example. If I give you 71 to the power 162. Last digit must be 1. Second last digit is equal to unit digit of product of 2 and 7. 2 7 are 14, hence 4 here. So last two digit of this particular expansion is equal to 41. Now let's discuss category 2. Number that ends with 3. So we have to find out last two digit of 13 to the power 789. First method is we can solve it by binomial expansion. 13 to the power 789, we can write it down as 10 plus 3 to the power 789. And then we can use the binomial expansion. Or else we can also write it down as 20 minus 7 to the power 789. And then we can use the binomial expansion and the same method as we have used it for the unit digit 1. Now we can have another approach as well. We know that 13 squared, last two digit is 69, and 13 to the power 4 will be 69 square and last two digit will be 61. So 13 to the power 4 last two digit is 61. Now we have given 13 to the power 789. 789 we can write it down as 4 into 197 plus 1. Hence this given term we can write it down as 13 to the power 4 to the power 197 into 13 to the power 1. Or we can write it down as last two digit of this particular expansion is same as that of 61 to the power 197 into 13 to the power 1. We have seen last two digit of this particular expansion is quite easier. Last digit is must be 1. Second last digit is given by product of 7 6 42, so 2. So last two digit is 21 into 13. So last two digit of this particular expansion is given by last two digit of 21 into 13. And that is equal to last two digit is 73. Hence last two digit of this given expansion 13 to the power 789 will be equal to 73. Thanks for watching the video.